Sorry, Patrick, lost you for a minute there. So, yeah, cap can's in, wired up, everything's super solid and looking good. These resistors measure within spec, you know, a little high on the droppers, but not bad. Your 1K is about 1.1, this 18K is about 19K, and this 18K is about 21K. But yeah, we got great connections everywhere, so you got a really solid power supply, ground, and filter cap situation. I've removed your safety ground from the transformer bolt and bolted it down tightly, and we'll go to chassis right here, heating up the big iron again. And I pulled your center taps off of this mounting bolt, and it doesn't have a caps nut on it, so I will replace it with one that does, so that this transformer won't come loose ever. And then I was thinking, you know, because the last guy did the filter caps the way he did, and you know, left a lot of muck, we could go here with your center taps. Traditionally, it's here a little further from your output tubes, so maybe we should just stick with tradition, because, you know, the chassis is a little scarred up anyways. So I think we'll not join the filter cap ground spot, but somewhere nearby, although that is tempting. But I think it's a little too close to too much sensitive stuff. So we'll go here. This is your old caps nut. I also took your death cap out and put it in the Patrick bag. This is a nice, you know, it's just like the other blue molded Ajax quality. It's 0.047, so that is a value in your tone stack. If this one were to ever die, you'd have a replacement, so that's pretty cool. Yeah, so let's scuff the chassis up a bit so that we get a good solder connection. Looking for my favorite chassis scuffer. Did use it for the tape machine. There we go. Yeah, that's good. Put a nice blob right there. Land that right there with it. And here we'll go about there. Good. Good. Tune this with the little iron first. Drop a nice blob right there. It should be both. Good. Get our little safety ground out of the way for a sec, and our bias supply feed. So we don't cook them. A little more. That's actually probably pretty good. Yeah, okay. So we'll drop our power in one while we're here. It's already tinned. Time with pliers. That's pretty beautiful. And these guys. Beautiful. That one's a little high stakes. Turned out great. That is not going anywhere ever. I like to poke at them pretty hard with the chopstick after they cool to make sure. Yeah. That's a bond. Okay. So, we've nicely got your center taps isolated to ground in their own little spot off the mounting bolt. Same with the power safety ground. And freed up this post to do what it does best, which is hold your transformer in place. And filter cap's done, resistors pass. Next up would be bias cap, which I don't have yet, and cathode bypass caps, which I don't have yet either, but are on the way. And then after that, it's just the NFB foot switch mod if you decide you want to do that. So we're looking pretty good. Depth cap out. A little bit of flux cleanup to do here after it cools, but everything went in really solidly and really looking good. Okay, put that on pause for now. So yeah, looking real good. Dummy load in so I can check some voltages. And with the new filter caps, the first preamp node is 255 Schematic says 240, so that's well within spec. That's really good. Schematic says 320 at this node, 335, good. 400 at this node, and we got bias wiggling. We got 413. Yep, good. And then 420 at this node, so probably 430-ish. 425, yeah. Great, so everything power supply wise, which is the thing we just changed, totally measures in spec and great. And I gave it a quick play test and it sounds awesome too. So that stage is good. Next I'm going to pull up legs of these existing cathode bypass caps and see if they really need changing or not. We'll measure them on the Sencor. Alright, we're going to look at your cathode bypass caps on the mighty Sencor cap tester, which tests caps at voltage. So this part of the circuit's fairly low voltage, so 25 rating is fine. Here's your first gain stage cathode bypass cap. It's one of these Ducati ones that you do see in the old Fenders. They were stock, but really only ever used in Princetons, maybe Champs. It's drifted out of spec, so it's supposed to be 25 microfarad. It's 38, which is too far away, changes the cutoff frequency, and more importantly, leakage. Yeah, so it's leaky. Presents DC at the other end of this node that it's supposed to be blocking DC from. So I lifted a leg on these cathode bypass caps too, the black ones here that are also stock, and they were not leaky and not out of spec. They're 29 instead of 25, which is totally within spec and just fine. Let's check your other Ducati one. I've lifted a leg on it too. Sorry for the camera flailing around here while I work with one hand. Okay, so that guy's clipped in. And yeah, 37, 38. So too high leakage. Yeah, so those gotta go, but these can stay. And that's the nice thing about having the Sencors. You don't just shotgun a bunch of parts that are fine. So we've determined that we'll replace the two Ducati ones and leave those. Those new Sprague cathode bypass caps are in, looking good. The values clearly shown for the next tech in 25 years when he wants to check them out. All right, on to the mod for the NFB. Okay, and then for your foot switch negative feedback on off mod, we're gonna pull this reverb RCA jack out, replace it with an isolated, insulated one so that the shield isn't connected to chassis ground, so that you can use it to connect your negative feedback tap wire off your speaker jack that goes to your negative feedback resistor, and then off to the, we'll break that connection, send one end to the sleeve of this new jack and the other to the tip, so that when you close your foot switch for the reverb, it connects the negative feedback loop in the way it was designed. And when you open the switch, click it again, your negative feedback is disconnected, and the tremolo still works because it sees ground through the shared shield of the cable, not via the chassis anymore, but via the almost ground of just the negative feedback resistor, 2700 ohms looks like ground to the first stage of this oscillator tube in your trim circuit. And that's all the foot switch for the trim does, is starts the oscillation. It doesn't affect anything downstream of the oscillator. So it's just, does it start, does it stop? And my mod keeps it so that it does. And then there's no holes drilled, no new parts really, except a floating jack. And you have a little boost pedal on your reverb switch that you probably never use because you just walk to the front of the amp and turn up the reverb. Okay, so we're looking at the bias on your power tubes here. Too hot. So your beautiful RCA 66s have a max plate dissipation of 12 watts. You're hitting 11. Supposed to be maybe 70% max, so 8 or 9. So we want to get this milliamp rating down to like 21 milliamps of plate current. But unlike its big brothers, there's no bias pot on a Princeton, so we have to either change that resistor or add a pot. I think I'll add a pot because if you ever need to change power tubes, you can just adjust it easily, like on the big boy amps, using this little trim pot that I place right about there. I don't have to drill a hole or anything like the big amps, but it just gives you more flexibility in the future for swapping power tubes and doing a quick bias adjustment with a screwdriver instead of a soldering iron and new components. Okay, now we're perfect. It's you know, good 70% max plate dissipation. We've added a trim pot to your bias circuit so that you can adjust the bias whenever you get new power tubes without having to solder in a different resistor value there. Just turn the pot. And this baby's ready to get buttoned up and go. Looks really good. Sounds really good. There's your new can cap from below. Real nice. Alright, so we're in great shape. We got this thing biased up at 67 or 8%, 20 milliamp per side of plate current. And we've got your adjustable trim pod in there so that you can change the bias whenever you need to, put in new tubes or whatever. Also, I want to show you the foot switch jacks. It's important that you hook your foot switch up correctly when you connect yours. So the white one is always the trem one, and the one with the braided shield around it is the one that goes to the old reverb jack, which is now your fancy gold floating negative feedback on off switch jack. It's just important that you connect them right or it won't function properly. But it functions great right now. So yeah, so it adds quite a gain boost and a nice bit of dirt depending on how driven you are already. And it still turns the trem on and off when you press the vibrato side of the switch. And then the dirt with the vibrato. And you can always tell what your versus not clean is, you know, which state your switch is in. Just play a chord, step on it. Probably can't tell on the iPhone, but it's there, it's big. Anyway, it's probably hard to tell on the iPhone because it'll be all distorted and compressed and blown out. But yeah, everything's great, and now you just, the switch doesn't control reverb anymore, but reverb's always on, and you just turn it up whenever you need it.